So let's look at 36. 36, we have to write the equation of the hyperbola with vertices at 3, 0 and 3, 6, with asymptotes at y equals negative x plus 6 and y equals x. Now, when we do this, remember, the easiest thing to start out with is to label where your vertices are on a rough sketch. That way you'll be able to tell what direction it's opening. So vertices at 3, 0 and 3, 6. If our vertices are above one another, what direction does this have to be opening? Up and down. So if it's an up and down hyperbola, which comes first, the chicken or the egg, the x or the y?
The chicken. Yeah, the chicken came
The y is going to come first because it's going up and down. Next is the easiest thing to figure out is your center. We know that our center is going to be at the midpoint here. It's going to be at 3, 3, I believe. So we have an h and a k of 3. And 3. Now, going back to about how we worked with the asymptotes. Remember, when we dealt with our asymptotes, we had vertical one. We had a simple formula for that. When you had your vertical asymptotes, you knew that y equaled k plus or minus a over b x minus h. Well, we know that the slope, so we knew the slope, because you had the slope of those was what? 1. One of them had a slope of 1, the other one had a slope of negative 1. Remember that from the beginning parts? Yeah. So we know that, let's see this, so it was a over b with 1. I copied 36, didn't I? Oh, okay, for some reason I thought I copied 35. Yeah, a over b is 1. So if a over b is 1, that means that a and b are the same. So wouldn't it simplify just a and b both being 1, no matter what? So that means that a is 1, b is 1, which means a squared is 1, and b squared is 1. So, no, it is a hyperbola because it says these are hyperbola. It's a hyperbola because it has an asymptote. Circles won't have the asymptote. Yes, sir.
Did it tell you that the slope was 1?
Yeah, when you go back to, I'm using the positive. We had that's when they had the asymptotes where it was saying that one was the 6 minus x or negative x plus 6. The other one was equals 6. That way we knew that it goes through like that. So then you have that. Now to find your c squared value. Or wait, did we even need to write out? We just write the equation, wasn't it? Oh yeah, we're done then. Fill in the blanks.
So then I just
your a squared value is 1. Your b squared value is 1. You have your h and k of both 3s.
So just ignore the first asymptote and look at the second half.
You can go either way, because
What number is this?
because remember it could be plus minus. It's just positive.
Murphy, I think you might have done something wrong.
Mark, do you know you can do
Yes.
it already?
But then the b value would have to also be 3 because the slopes are 1.
I'm gonna do this best.
No, Murphy, you did something wrong.
Yeah, Murphy,
You did something wrong.
No, I didn't.
Yes, you did.
Look at the answers.
It should be over 1, isn't it?
No, the answer's over there.
Yeah.
Uh-oh.
I think
Are
we
we
need
supposed to know
to
when
delay
we're
this
not
quiz
gonna
another
play?
day.
Oh, I see. Yep, I see what I did. Okay. I'm sorry. I see what I did here. So this is supposed to be 1, and you're right. Devin, you're right. I was skipping ahead. I was thinking of it as the a over b. I was thinking the a over b both being the same value has to simplify to be in 1, and I forgot the fact that yes, the distance of a is 3. So this should have been 3 over 3, so these are both 3's here. My fault on that one. I was simplifying a fraction prior to when I needed to simplify a fraction. I'm so used to always simplifying fractions, I forgot the fact that here you don't want to because the 3 has to be a 3. So yes, you're right in that case. Sorry about that. Yes, sir?
With the B is the distance between the center and what?
What's technically called the covert, it's not called the covertex, I call it that, it's called the, I think we looked up the name of it yesterday, it was the conjugate axis.
Okay, and where is it in this?
We don't need to worry about it. It would be placed here, and it would be here. So you create this rectangular box like this.
But how do you know that?
Yeah.
But like,
We don't need to know it.
okay, but how are you gonna get the A over B then?
We know that A over B has to equal 1.
Oh.
If you know what A is, what's 3 divided by what equals 1? 3. And that's where I made the mistake real quick of going, oh, it's got to be a simplified fraction of 1 over 1, and I skipped ahead and did that. So I forgot the fact of using it. We were given the 3 to start with to finish that out. Which one? Sure.
Which one?
Yeah, write out 15. Sure.
I think I just did something wrong.
So on 15, you are given x squared minus 9y squared plus 2x minus 54y minus 80 is 0. So we have to do a little bit of completing the square. So we're going to regroup the x's and y's and send the constant packing. So we have x squared plus 2x plus blank minus 9y squared minus 54y plus blank equals 80 plus blank plus blank. Yes, sir? Yes, failure's in there, right? So the first part, the x squared, no big deal. That's going to be easy to set up. The second one we have to simplify out by taking the 9 out. So we can't complete the square with a coefficient not equal to 1. So just rewrite it real quick. We'll have x squared plus 2x plus blank minus 9 times the quantity y squared minus 6y plus blank is 80 and something.
What did the other
And then we took out a negative 9, so we got to put back a negative 9 blank. Okay? Sure. What's half of 2?
Half of 2 is 1.
What's 1 squared?
1 squared is 1.
So in our terms, x plus 1, 1 here, 1 there. What's half of 6?
3.
What's 3 squared? And then bring the 9 over here.
Minus 9
Never
Yeah,
mind,
it's
wait, I got it. I figured it out.
Why am I getting 0? I should be getting 0 though. What's that?
The lines just intersect.
Yeah, like the hand in the back just says intersection at -1, -2.
Oh. Is 15? Oh, I got you. Okay. Yeah, because what happens then, if you get this equal to 0, you can't divide by 0. So that just, at this case then, these would both be over 1, right? Because that doesn't change anything? And it's going from there. So they're saying that they just, that's why they're saying that the asymptotes just intersect, and there's no, yeah.
Is there really something
I don't believe so. What I try to do with the quiz is I'm trying to set it up where it's just a couple graphs, just a couple standard form equations, and a couple, write the equation given specific
like that? Is it like
specific stuff.
Python?
Similar, yeah. We didn't use the same ones because we actually did the hyperbola stuff before they did, because for some odd reason we got a date ahead of them somehow, and then I knew that I was going to. I knew that all of us were out yesterday afternoons. This always probably a joke yesterday for the Alpha 2 books. So that's why. But yeah, the way I'm looking at it is going to be a couple graphs, a couple write the equation in standard form where you'll have to do your complete the square and identify the center, something like that. And then where you're given a vertex and a focus, write the equation, vertex, co-vertex, things like that. The one probably just did a second ago with the hyperbola where you're given that and an asymptote.
Is there
Yeah, you
a
can.
point of
We're
tangent?
given all that stuff.
What's that?
You said like the one that's.
Yeah, very similar to something like that. Just remember that it's the distance is 3, not 1. When you simplify it, you'll be okay. If that's the problem that's on there.
Wait, is there a point of tangent?
There very well could be.
So yes.
Zero.
Point of tangency, remember when you did that back in the hyperbolas? We did that point of tangency where you went up a little bit and then you had to take that from the center and go back the other direction to write the equation of the
Oh
line.
boy.
Can we do one of those?
Can I have like an inherited one instead of a note card?
Yeah, let me get one of those out here.
Wait, are you taking this?
No, you guys can keep that, it's not a big deal. You can see here, right the point of tangency, that
Murphy,
was.
didn't you tell Sydney that you were working it?
That'd be
I'd
super
rather just have it.
Yeah.
You do it all.
Let's see, point of tangent line, all right. So write the equation of the line given by this. So this is a parabola point of tangency. Bless you. So we want to write the equation of the line that's tangent to excuse me. Write the equation of the tangent line to the parabola given by y equals x squared through the point 1, 1. So y equals x squared, is that a up and down or a left and right or just an up, a down, a left, a right? What type is that?
Oh. Murphy, is there ever gonna be ones like this that are like y squared?
Could be, it's the same
Or
sound.
just do it the same way?
Yeah, it's the same way. Remind me to run back to the office a little bit here and get you guys, we can go first now. So we know that this is gonna have to be, goes at the origin, then it goes up, okay? We're looking to find the equation of the line that goes through the point 1, 1. So if I call this just 1, 1 here, and it's going to be tangent through it, means it's going to touch it at exactly one spot. For lack of better terms of drawings. Okay. So in order to do this, what we're going to find is that whatever the distance is to the focus, the distance from here to here is going to have to be the same distance from here to here. And that's what's going to allow us to figure out what our lower value is in this case, since it's opening upward. Okay. So we need to figure out where the focus is. Remember, the generic form of the equation of the parabola was 4p x squared. So I have to set 4p equal to whatever the coefficient of our x squared is. In this case, it's equal to 1. So that means my p value in this case is 1/4. That places the focus of our parabola at 0 and 1/4. You okay with that so far? Where the focus is. Remember, the value of p is always the distance from your vertex to your focus. We know that it has to be looking upward because it's a positive value of p, since the coefficient of x squared is also 1. So we knew it was opening up. So what we do now is we're going to find the distance from here to here. So we just use a distance formula. Square root, change in x, 1 minus 0, quantity squared, plus the change in y, 1 minus 1/4, quantity squared. I get 1 minus 3/4 quantity squared, so it's either 1 plus. Get that. You okay with that so far? So when I do this, my fraction becomes 9/16. Everybody okay with that? What's 1 plus 9/16? Very good. I get the square root then of 25/16, otherwise known as 5/4. So now that means the distance from here to here is 5/4, which means I have to go a vertical downward distance of 5/4 from the starting point of 1/4, and that places me where?
So 1/4.
1/4 minus 5/4 is
1.
-1. So this point here is at 0 and -1.
So you subtract
What is this?
1/4.
Because I know that the distance from my focus, which is at 0 and positive 1/4, I know the distance to here, and will be 0 comma something else because it's vertical. This overall distance has to equal 5/4. I'm moving downward, so all I took was 1/4 subtract 5/4 because I'm moving down, and I get -1. I get -4/4. That's how that works. You will see a lot of these things with those fractions where you're going to get a focus value, some fractional amount, and then your distance should wind up with a working fraction that'll, I don't want to say alleviate, but will not be as frightening to work with as it looks like it will be. So it gives me two ordered pairs at 0 and -1, and 1 and 1. Find the slope. I mean, you have to go up. We're trying to find the slope between these two now to write the equation of the line. How many do you go up? You know, 2 up 2 over 1. What's your slope? 2. What's your y-intercept? Y equals 2x minus 1. Oh, algebra, you're so smart. The equation of the line that's tangent to this on that chart. Heck of a lot of math. Basically what I start out with is I get the focus. Oh, the last step? Okay. You got this point okay, right? We can do change y or change x to find your slope. I figured it's pretty quick to worry about. It's going from from -1 for change in y to +1 is 2. So my change in y, my vertical was up 2, and I went to the right one, so my slope was 2. My y-intercept is -1. I just did it the quick way as opposed to saying, oh, my change in y, so it's going to be 1 minus a -1 over 1 minus 0. I get 2 over 1, so my slope is 2. I know my slope is 2, then I go y minus -1 equals 2 times x minus 0. This becomes this, so I get y equals 2x minus 1. It was just, since I'm dealing with a y-intercept and a very easy slope to walk, I just thought it was faster just to say it as opposed to doing the long-form algebra to show it. That's all. Yeah. I thought I had another one. I can dig up another one of these as well. I knew I had note cards around here somewhere. It's exciting.
Are these the ones with the graph on them?
Wah, wah, wah.
Open no.
He goes here as far as
That's right.
Why are there
Isn't
so
it
many
like a
note
shop?
cards?
I can't count. These are they stick together so much.
Oh, they're all the good ones? Yeah.
Two.
You don't know our system.
I go like this.
No, I don't.
Need another one? Did I give you enough?
We need some more.
The other one?
Yeah.
What's that? I'm gonna do another one.
Pricing Mark.
You guys need another one, you said?
Yeah, we need some more. Yeah, Mark doesn't know how to count.
Alright, where's my?
Oh, we need one.
We need two more. We're lying.
Never mind.
What a shout.
He hates all of you. He really does.
So, this is stuff we're learning.
Alright, let's see.
Ignore.
No, I had one in my face.
I'm sorry.
Okay, so the equation actually takes 1 is 4 y minus k.
Okay, so it's an x squared. Never mind, we've done it. Let's do another one of those. Equation of the line of the do the same thing. Find the equation of the line, or find the equation of the tangent line to the given parabola that goes through blah blah.
Does it work?
So we have an x squared parabola with a negative. I don't have any. I think a lot of these goes x squared because it's so much less. Because you're going up and down, it's a little bit easier than trying to go left and right for slopes. That was x squared. So again, what we do is we take our p-value, or our coefficient of the y-value, we'll set it equal to 4p to figure out what direction it's going. So 4p is -2, which means our p-value is -1/2. What direction is this going? Up or down? Down. X squared, so it's opening downward, negative. It's got the center at the origin. So our vertex is at the origin. Our focus is at -1/2. We want to go through the point 2, -2. So we need to find the distance from here to here. The distance from there, so that's going to be the point of 0, -1/2. And the other one is at 2, -2. We're going to find that distance first. 2 minus 0, quantity squared, plus -2 minus -1/2, quantity squared, and square root it. Right off the bat, we're going to get 4 plus, well, the next one would be what? -2 plus 1/2, so it would be 1.5 or 3 over 2, -3 over 2. Positive 9/4. What am I going to change that 4 into to be able to add it to 9/4? 16/4. And hey, look at that. What's 16 and 9? 5/4. You get 25. So the square root of 25 over 4 is 5/2. See what I'm saying about, even though it looks like it's going to be god-awful, you wind up with fractions that are going to work. So we have a distance then of 5/2. Okay. So I'm starting at -1/2, and I'm going to add 5/2 to it, which means I'm going to go up to what? Two. -1/2 plus 5/2 is 4/2, otherwise known as 2. So I know now these two distances are the same. Now I can write the equation of the line. I have 2 ordered pairs. I have it at 0, 2, and the other one is at 2, -2. If I go long form here to find my slopes, the change in y, what's that? 3 -2? Oh, it's a 2, the pen just moved. Sorry, it's 2 -2 there. When I circled it out, I gotta clean these the cameras here. So you have your change in y over change in x. Does everybody agree that our slope here is going to wind up being negative? Because the line is moving downward towards the right?
Yeah.
Change in y, we're going to have 2 minus -2 over 0 minus 2. Bless you. I get a slope of -2. Perfect. And we are given our y-intercept at +2. So our equation is y equals -2x plus 2. Thank you. I'll be here all week. Tip your waitresses. Yes, ma'am.
So far you have it.
That's good.
I said, he said, I'll be here all week. I really am here all week.
Jenna, save me, please.
Okay, so the distance is like, okay, so what you're doing is you're adding the distance to the focus.
Because the distance from the focus to the end point on the curve has to be the same as the distance going the other direction. Because you create a nice isosceles triangle. Perfect. I mean, we could find angles here if you want.
No, we'll pass on that. I think that's going to be on the test too.
Yeah, so make sure you guys get your general formulas written down, things like that. I don't think there's any real shortcuts for anything. There really isn't much shortcut for really anything.
So there's 10-2, 10-3, and 10-4.
6 maybe? 7? So most of you should be able to get through. I'm trying not to make it too long-winded, shall we say. So I'm almost thinking about cutting back on a question, and then that way we can save that one for next week.
Let's do one problem for each section.
Yes, sir. Anything else? Throw up around here.
Yeah.
All right.
I said